In this lecture, the sources of information available for the selection of dairy bulls are discussed. In South Africa, breeding values are estimated for the following traits. Production traits, which are milk, butterfat and protein yields, as well as butterfat and protein percentages. For udder health, we estimate breeding values for somatic cell score, which is an indicator trait for udder health. For fertility, we estimate breeding values for calving interval. Functional herd life is our longevity trait. We also estimate breeding values for the persistency of milk production. And then for Jerseys and Holsteins, we estimate breeding values for linear type traits, which is conformation and other traits. And we have 18 traits for the Jerseys and 17 for the Holsteins. There are therefore quite a lot of breeding values available for the selection of animals, but this makes it actually very difficult to do the selection. For this reason, breeding values are combined into selection index values, where the different traits contributing to the selection index are weighted according to the trait's specific economical value. Now, the breed societies are actively involved in the construction of these indices because it needs to reflect the breed's specific breeding goal. Total merit indices of the different breeds are therefore not the same. Some breeds have more than one total merit index, which can be used for the selection of the animals. Now, in these total merit indices, all the traits are then combined into one selection figure using the economical values of the different traits, where the economical values are being determined by the milk price structure of the country, the markets being served, as well as the weaknesses of the population. It is therefore not a good idea to use another country's total merit indices for bull selection, as it's not applicable to our own country's marketing situation or weaknesses of our population. Now, sub-indices are also constructed to show the worth of the animal for different components, for example, with regards to other traits, feet and legs, body conformation, and production itself, and the breeder can use these sub-indices then to do bull selection to address specific needs within his own herd. The principal total merit index of the Holsteins is called the Holstein Selection Index, or the HSI. And in the pie chart, you can see how this index is being constructed. A 17% emphasis is being put on butterfat yield, 21% on protein yield, 8% on efficiency, 8% on type, 1% on angularity, 11% on others, 6% on feet and legs, 10% on herd life, 5% on somatic cell score, and 13% on intercalving period. Note the negative values being put on angularity, somatic cell score, and fertility. That is because of the breed-specific objective to make the cows a bit less angular, and of course lower somatic cell score are associated with better udder health, and of course you want shorter calving intervals, which is an indication of better fertility. Also note that milk yield itself is not included in this index because it's highly genetically correlated to butterfat and protein yield, meaning that milk yield will automatically also improve if you select on this index, but by not including milk yield, it also will result in butterfat and protein percentages to be improved. The principal total merit index of the Jersey breed is called the SINET, and you can see the construction of the index here. 20% emphasis is being put on functional type in our total index, 40% emphasis on production, 10% on functional other, 20% on reproduction, and 10% on longevity. For the Ayrshire breed, the total merit index is called the Logix Merit Index, or the LMI. Now, unfortunately, for the Ayrshire breed, there is not enough linear type traits available for a genetic evaluation, so we do not have sub-indices for other body conformation or feet and legs. So in the pie chart, you can see that a 20% emphasis is being put on milk yield, 12% on butterfat yield, 25% on protein yield, 17% on herd life, 11% on other health, and 15% on fertility. Now, there's also some disadvantages involved in the use of selection indices, and the one is that a bull might have a very good selection index because some of the breeding values for some traits are very extreme, very high, and that might hide less desirable breeding values, and those less desirable breeding values might even be below the specific herd's genetic levels for those traits, and therefore those bull will not improve the herd for those traits. Furthermore, the genetic profile of the animals in the top might differ quite a lot. Some breed bulls might be in the top because they have very high production figures but are not so good in some of the other traits, while other bulls might be the other way around, which is actually not a bad thing because that's a way to maintain genetic diversity within the breed and within the herd by using bulls which have different genetic profiles. So it's recommended to use the total merit indices to draw up a short list of the bulls that you consider using in your herd. But you always need to consider the individual breeding values and sub-indices of these bulls to make sure that they are actually better than your own herd's genetic levels before making your final bull choice. Now, all countries do their own genetic evaluations, but the breeding values and selection indices of different countries are not comparable. And here is a list of reasons why. First of all, countries might differ with regards to the way the trait is being defined. For example, for longevity, some countries use functional herd life, while other countries use productive herd life. Some countries measure dairy form, while other countries measure dairy strength, and some countries measure foot angle, while other countries measure heel depth. It is therefore not the same trait that is being used. Furthermore, countries might differ with regards to the data they include in the genetic evaluation. For example, for production traits, countries might differ with regards to the number of lactations they include in the evaluations. Most countries include the first 3 lactations, but there are countries that include only the first 2, and some countries even include all available lactation information in their genetic evaluations. Countries might differ with regards to the unit of measurement being used. Most countries, for example, measure production in kilograms, while the USA still measure in pounds. Of course, the genetic parameters, the heritabilities and genetic correlations differ across countries because different populations are subjected to different selection intensities, and the gene frequencies therefore differ across countries. The methodology used for the genetic evaluation might differ. Most countries today use test time models for the production trait evaluations, but there are still some countries using lactation models. Furthermore, some countries use fixed regression test time models, while other countries use random regression test time models. For longevity, some countries use BLUP methodology, while other countries use survival analysis. Then the format of publishing the breeding values might also differ across countries. Most countries use EBVs, while the USA publish their breeding values as EPDs, where an EPD is half that of the EBV. Many countries also present their breeding values, especially for conformation traits, as breeding value indices, where the breeding values are then expressed around the active breed average, which is set to 0 or to 100 even. And then lastly, the definition of the base year differs across countries. The older the base year is being used, the higher the breeding values of the active animals will be, and this makes, of course, a huge difference in the comparability of the breeding values across countries. However, due to AI, bulls have daughters all across the world, and it has become essential to compare bulls on an international level. Due to the increase in global selling of semen, embryos, and animals, a serious demand for accurate global comparisons of animals developed, especially with regards to bulls having daughters in different countries. And that is why Interbull was established and international genetic evaluations were developed. Now, luckily, AI resulted in genetic linkages forming across countries, which enables Interbull to estimate genetic correlations between the different countries. The point of reference that is being used for international comparison is the performance of daughters of national AI sires, therefore local AI sires, in comparison to performance of daughters of foreign sires within the same herd. And that is why it is so important that our South African breeders also use our national AI sires in their herds, because this is a point of reference with which the genetic levels of different countries are being established by Interbull. Now, Interbull is based in Uppsala in Sweden, and currently 32 countries participate in these international genetic evaluations, of which South Africa is also one. So due to AI bulls of all across the world having daughters in different countries, an international genetic ranking can be set up. Breeding values estimated from these international genetic evaluations is called MACE. MACE stands for Multiple Across Country Breeding Values, EBVs. MACE empowers countries to know where a foreign bull will rank genetically in their own populations, even before that bull have measured daughters in the relevant country. It is therefore a huge help to prevent the dumping of inferior foreign semen in countries. So Interbull stands for the International Bull Evaluation Service. They are a subcommittee of ICAR, the International Committee for Animal Recording, and they are based in Uppsala in Sweden. They are responsible for the international genetic evaluations of dairy cattle, and they predict MACE breeding values for 40 traits. 32 countries are currently participating, and 6 breeds are involved. The Holsteins, red dairy cattle, which is mainly the Ayrshires, the Jerseys, Guernseys, Brown Switzers, and Simmentaler. 5 evaluations are done per year, 2 test runs in which countries have to participate when they introduce new developments in their own genetic evaluations, and then the 3 routine runs in April, August, and December. Please feel free to look at the website. There's a lot of information on exactly how MACE works, and you can also see the genetic correlations that they estimate between the different countries and the number of common sires involved across the world. Not all bulls qualify to participate in MACE genetic evaluations. Only official AI bulls with daughters in at least 10 herds in its country of birth is included in the MACE genetic evaluations. Now, MACE is being expressed in the unit of measurement, genetic parameters, base year definition, and the publication format of the breeding value, which means that every country gets its own set of MACE breeding values, and this set will then include all the AI bulls all across the world that participated in the genetic evaluation. Now, these MACE breeding values are then directly comparable to the country's own national breeding values. Of course, we are now in the genomically era, so there is also something like GMACE. GMACE is genomically enhanced breeding values, which is now estimated by Interbull for the young AI bulls with no daughters yet. Now, this is currently only done for Holsteins, and this GMACE is then also expressed according to the unit of measurement, genetic parameters, base year definition, and publication format of the breeding values, so that it is directly comparable to the country's own national breeding values. It enables our breeders to know how a young foreign bull will compare to its own herd's genetic levels. So this slide indicates to you the effect of MACE genetic evaluations on genetic rankings of the AI bulls across the world. Different countries do their own genetic evaluations, and then the breeding values of the AI sires that qualify are being sent to Interbull with daughter information of these bulls. Interbull then do a joint genetic evaluation, international genetic evaluation, and sends back the MACE breeding values to the different countries that participated, including all the AI bulls from across the world in the genetic ranking of every country, which is then directly comparable to the country's national genetic breeding values. Countries participating in MACE genetic evaluations differ in the way that they apply MACE and GMACE in their own genetic evaluations. In South Africa, the young foreign bulls' MACE and GMACE breeding values are blended with their South African breeding values until their South African breeding values, based on measurements of their South African daughters, reach a reliability of 80%. Furthermore, the mid-parent breeding values of their daughters, the young heifers at that stage not measured yet, and young South African sons that does still not have measured daughters, of these MACE bulls are then based on the Shire's blended MACE EBVs. The bottom line of the implementation of MACE is that our breeders have to know how a bull's genes are expressed in the South African environment, and they have to know where the bull ranks in the South African populations. But is MACE still relevant in the genomic era? Today, the major dairy countries all do genomic evaluations. So they genotype all the foreign AI bulls being used in their countries, and the genomic information are therefore included in their own genetic evaluations. They therefore do not need MACE for these bulls anymore. However, they still need MACE for older foreign bulls that were not genotyped and do not have daughter-proven breeding values in their own country. However, smaller countries without genomic evaluations, for these countries MACE are absolutely essential.